Welcome students. Today we will study some standard results of regular hexagon and try to find the resultant of forces which are acting along the sides and diagonals of a regular hexagon. Suppose that ABCDEF is a regular hexagon, then each interior angle of a regular hexagon will be equal to 120. First one. And if we join A and C, A and D, A and E, then angle BAC, angle CAD, angle DAE and angle EAF will be equal to 30 degree, because total angle BAF is equal to 120. Now angle BAE will be equal to 90, because 30 plus 30 plus 30, these three angles, sum of these three angles will be equal to 190. This means BA is perpendicular to AE. We can take AB as x-axis and AE as y-axis. If each side of regular hexagon is equal to A, then length of AC will be equal to under root 3A, length of AE will be equal to under root 3A. These are some facts about regular hexagon. Let us take some examples and find the resultant of forces that act along the sides of regular hexagon or diagonals of the regular hexagon. Suppose ABCD is a regular hexagon. We have to find the resultant of forces equal to 5, 7, 18, 5, 9 and 19 kilogram weight acting along AB, CA, AD, AE and AF as shown in figure. We take AB as x-axis and AE y-axis. We take A as origin. Now force equal to 7x along AB, 18 CA. Direction of this force is along CA, and then 5 kilogram weight along AD, 9 kilogram weight along AE and 19 kilogram along AF. Now we resolve all these forces along x-axis and y-axis. AB, we take AB as x-axis and AE as y-axis. Now x component of all these forces along x-axis will be equal to 7 cos 0, because 7 is along AB and AB we have taken as x-axis. This means this force makes an angle 0 with the positive direction of x-axis. X component of this force 7 kilogram weight will be equal to 7 cos 0. Next 18 kilogram weight whose direction is along CA makes an angle 210. This angle will be equal to 210. This angle actually x component of this force will be 18 cos 210. 18 cos 210, we can write it as 18 cos 180 plus 30. This cos 180 plus 30 will be equal to minus 18 cos 30, minus 18 cos 30 degree. Actually there is a negative sign, minus cos 30, minus 18 cos 30. Next, x component of force 5 kilogram which is acting along AD is equal to 5 cos 60, because this total angle is equal to 30 plus 30 60. X component of force along AE which is equal to 9 kilogram weight, 9 kilogram weight is equal to 9 cos 90, because AE makes an angle 90 with the positive direction of x axis. Force acting along AF which is equal to 19 kilogram weight makes an angle 120 with positive direction of x axis. This means this x component of this force is equal to 19 cos 120. By putting the values of all these angles of cos 30, cos 60, cos 90, cos 120, we get 7 into 1, because cos 0 is equal to 1, minus cos 30 is equal to minus 18 into under 3 upon 2 plus 5 into 1 by 2, because cos 60 is equal to 1 by 2. Cos 90 is equal to 0, this component will be equal to 0, and final last component will be equal to 19 cos 120. Cos 120 will be equal to minus 1 by 2. After simplification, we get x component of all these forces. Sum of x component of all these forces is equal to minus 9 under 3. Similarly, we can write y component. We can take sum of all the y component of all these forces. We denote this y component as capital Y. This will be equal to 7 sin 0 minus 18 sin 30 plus 5 sin 60 plus 9 sin 90, 19 sin 120. After putting the values of sin 0, sin 30, sin 60, sin 90 and sin 120, we get y is equal to 12 under 3. Now, a resultant of all these forces, suppose a resultant is equal to r, which makes an angle theta with positive direction of x axis, then x component of this resultant will be equal to r cos theta is equal to x, and r sin theta is equal to y component of all the sum of y components of all the individual forces. After squaring and adding, we get r square is equal to x square plus y square, which will be equal to 243 square of x component of all the individual forces plus 432. This comes out to be 675. R will be equal to 15 under 3 kilogram weight. If we divide y by x, then we get, because x component is equal to r cos theta and y is equal to r sin theta, r sin theta upon r cos theta will be equal to y upon x. This means tan theta is equal to y upon x. From this relation, theta comes out to be tan inverse minus 4 upon 3. This is the direction of the resultant, and the magnitude of resultant is equal to 15 under 3 kilogram weight. Let us take another example. Suppose ABCD is a regular hexagon. Forces of magnitude 1, 2 under 3, 2, 4 under 3, 5 kilogram weight respectively act at one of the angular points of regular hexagon towards the 5 other vertices taken in order. Find the magnitude and direction of the resultant of forces. ABCD is a regular, ABCDEF is a regular hexagon. We are given force is equal to 7, uh, sorry, 7 not 7, 1 kilogram weight, 1 kilogram weight acts along AB, 2 along AC, along AC. This is along AC because we have given that all these forces act one angular point of the regular hexagon toward 5 other vertices taken in order. This means this force act along AC, which is equal to 2 Third force is 2 acts along AD. Next 4 acts along AE, and 5 kilogram weight acts along AF. Resolving all these forces along x axis and y axis, we take AB as x axis and AE as y axis. A is taken as origin. Then suppose their resultant is equal to R, which makes an angle theta with positive direction of x axis. Then x component of resultant will be equal to R cos theta. This is equal to theta. R cos theta will be equal to algebraic sum of all the x component of all the individual forces. X component first force 1 cos 0, because first force acts along AB, we have taken AB as x axis. This means this force makes an angle 0 degree with x axis. Therefore x component of this force which is equal to 1 kilogram weight will be equal to 1 cos 0. Second force which acts along AC, whose magnitude is equal to 2 makes an angle 30 degree with the positive direction of x axis. Therefore its x component is equal to 2 cos 30, and third force is 2 makes an angle 60 with the positive direction of x axis. 2 cos 60, 4 cos 90, next 5 cos 120. After putting the value of all these cos 0, cos 30, cos 60, cos 90 and 120, we have R cos theta equal to 5/2. Similarly, we get R sin theta is equal to 17√3/2. After squaring and adding, we have R square is equal to 223 and R comes out to be under root of 223 kilogram weight. If we divide 2 by 1, then we get tan theta is equal to 17√3/5, which gives the direction of the resultant. Suppose we take another example. Suppose we have ABCDEF is a regular hexagon and forces represented in magnitude and direction by the lines of AB, AC, AD, AE, AF act at point A. Then we have to find the resultant and magnitude of resultant and the direction of the resultant. Because forces are represented completely, means both in magnitude and direction by the lines AB, AC, AD, AE, AF, which act along at a point A. This means if we take magnitude of force P along AB, then along AC magnitude of force will be equal to under root 3P, because if length of AB is equal to A, then length of AC will be equal to under root 3A. We have already discussed about the regular hexagon, facts about the regular hexagon. Then AD will be equal to 2A, AE will be equal to under root 3A. Because magnitude of forces are proportional to the lengths of AC, AD, AE, AF. This means if magnitude of force along AB is equal to P, then magnitude of force along AC, not CA, AC, will be equal to under root 3P, and along AD will be equal to 2P, along AE will be equal to under root 3P, and along AF will be equal to P. After resolving along x-axis and y-axis, we have taken AB as x-axis and AE as y-axis. A is taken as origin. Then x component of all the forces will be equal to sum of x component of all these forces will be equal to P cos 0, under root 3P cos 30, 2P cos 60. This force along AE makes angle 90 with the positive direction of x-axis, therefore its magnitude, its x component will be equal to under 3P cos 90. Similarly, x component of force along AF will be equal to P cos 120. After simplification, we have x is equal to 3P. Similarly, y component of all these forces will be equal to P sin 0. We simply replace cos by sin, then we get y component of all these forces, and by putting the values of different angles of sines of different angles, sin 0, sin 30, sin 60, sin 90 and sin 120, we get y is equal to 3 under 3. Squaring and adding x and y, this gives r square is equal to x square plus y square is equal to 9p square plus 27p square, comes out to be 36p square. This means r will be equal to 6p. If we divide y by x, then we get tan theta equal to under root 3. This means theta is equal to 60 degree. Theta is equal to 60 degree. Students, we have learned about a regular hexagon, and if we have any number of forces which act along the sides of a regular hexagon or diagonals of the regular hexagon, then we can find the resultant and direction of the resultant. Now we study some condition of equilibrium of a number of coplanar forces which are also concurrent forces. What will be the condition of equilibrium if we have any number of forces which are coplanar and which are concurrent forces? Suppose that we have many forces, suppose F1 which act along OA, OB, F2 along OC force F3 and so on. We take a direction OX as x-axis and a perpendicular direction OY as y-axis and resolve all the given forces along x-axis and y-axis. Suppose that sum of all the x component of given forces, algebraic sum of all the x component of given forces is equal to capital X, and sum of y component of all the given forces along y axis is equal to capital Y, then their resultant will be equal to r square will be equal to x square plus y square. If this system of forces is in equilibrium, then resultant must be equal to 0. This means r is equal to 0 means x square plus y square is equal to 0, means x is equal to 0, capital Y is equal to 0. Any number of forces, system of any number of forces will be in equilibrium which is concurrent and coplanar whenever algebraic sum of x component of all the given forces will be equal to 0 and algebraic sum of all the y components of given forces will be equal to 0. That is, capital X is equal to 0 and capital Y is equal to 0. This is the necessary condition for the equilibrium of any number of forces which are acting at a point, which are coplanar and that is concurrent. If suppose x equal to 0 and y equal to 0, this means x square plus y square will be equal to 0, means r will be equal to 0. Necessary and sufficient condition of equilibrium of any number of forces which are coplanar and concurrent is that algebraic sum of their resolved parts along any two perpendicular directions in the plane of forces must be 0. Separately vanish the meaning की है, that is algebraic sum of x component of all the given forces must be equal to 0 and algebraic sum of y components of all the given forces must be equal to 0. If we summarize conditions of the equilibrium of forces acting at a point or on a particle, if we have suppose two or more forces, they will be in equilibrium if two or more forces acting on a particle are in equilibrium if they are equal and opposite. If we have two forces, if we have three forces, then according to Lami's theorem, magnitude of any force upon sine of angle between other two must be equal to magnitude of second force sine of angle between other two. Third force upon sine of angle between other two, that is Lami's theorem must be satisfied for the equilibrium of three forces acting at a point. Similarly, if we have any number of forces acting at a point, for the equilibrium they must be coplanar and algebraic sum of their resolved parts along any two mutually perpendicular directions must vanish separately. These are the three conditions for if we have two forces acting at a point. Second, if we have three forces acting at a point, then these forces must satisfy Lami's theorem. Third condition is that if we have any number of forces acting at a point, they will be in equilibrium if they are coplanar and algebraic sum of their resolved parts along any two mutually perpendicular directions are separately 0. These are three conditions for the equilibrium of any number of forces. Suppose we have an example. Suppose ABC is a triangle, equal to triangle, and E and F are middle points of the sides CA and AB. Forces 4P 2PQ kilogram weight act at a point in the directions of lines BC, BE, CA, CF, AB respectively. If system is in equilibrium, then we have to find the magnitude of P and Q, because all these forces act along BC, BE, CA, CF, AB respectively. Then we take A as origin and along AB, that is along force Q, we take x axis and a mutually perpendicular line we take it as a y axis, and we find that sum of all the x component of all these forces comes out to be q cos 0, 4 cos 120, p cos 150, 2 cos 240, p cos 270. X comes out to be After putting the value of cos 0, cos 120, cos 150, cos 240, cos 270, x will be equal to q minus 2 minus under root 3 by 2p minus 1, which will be equal to q minus under root 3 by 2p minus 3. Similarly, we can find algebraic sum of all the y components of all these given forces. This will be equal to under root 3 minus half p. Because system of forces are is in equilibrium, then individually these x component and y component of all the algebraic sum of x component of all the given forces must be equal to 0, and y algebraic sum of y components of all these forces must be equal to 0 separately. This means capital X equal to 0, capital Y equal to 0. Putting capital X equal to 0, this gives q minus under root 3 by 2 p minus 3 is equal to 0, and under root 3 plus half p is equal to 0. From these two equations we get p and q. Thank you, students. We will discuss some another examples in the another video. Thank you.